A quadratic function is one that has x squared as the highest exponent term in the problem. So it can have more than just x squared present. It could have an x term present. It could have just an integer piece. It just can't have anything higher than x squared, and at a minimum it has to have x squared in it. And so the parent graph that we're going to be working off of for all of our study of these functions is this just regular old parabola that's generated by the function f of x equals x squared. And so hopefully we're familiar with this type of graph and this type of function. But just to make sure that we remember how it operates, we've got this t-table that we'll work with to help generate kind of a pattern of values that we're going to use for all of our functions. So when we have an input of -2, if we square -2, if we do -2 squared, that means we're doing -2 times -2. So a negative times a negative equals a positive, so we're going to end up with an output of +4. And we can see that that's confirmed on our graph here. If we go left 2 and up 4, we are going through that location right there. If I plug in -1 for x, same thing happens. The negative disappears when I multiply -1 times -1, and I just get +1 as an output. So again, on my graph, I can see -1, comma 1 is going to be on my graph as well. 0 squared is 0, so that's why our graph goes through the origin right there. Well, try that again. Get the idea there. And then if I do 1 squared and 2 squared, 1 squared is just going to be +1, 2 squared is going to be +4, so we're creating the points that are on this side of the graph over here. It's probably worth it to also take note of the fact that we've got points at 3, 9 and -3, 9. So taken together, we can see that these points are not on a straight line. It's not a linear function. We have a curve, and that's because the x is squared. And we've got this pattern is from the vertex, from that bottommost point, the vertex, we go over 1, up 1 in both directions. Then we go over 2 from the vertex up 4, and then over 3 up 9. So you'll hear me say that quite a bit as we sketch out the graphs of these functions, even though we won't be using a t-table like this. Just like for the absolute value functions, we used the t-table to get started, but we eventually moved off of that and used our transformations. And so that's what we're going to see in the lesson here, where we're going to be translating our graphs, but we can also dilate them so we can stretch them in the vertical direction or shrink them, and then we can reflect them. So instead of having a parabola that opens upward, it can open downward. But in this first section, we're just going to focus on translations of these parabolas. And so the translations work just like they did for those absolute value functions. So we're again going to base everything off of our parent graph, that U shape with the vertex at the origin, and then we're just going to see how that graph is translated, how it's moved around the coordinate plane. So in this case here, with this -6 that's happening after the x squared has taken place, so that's going to be indeed a translation. And because that -6 is happening, that subtraction is happening after the x squared, so not inside of the function, but on the outside, it's going to be a translation that's going to be in the vertical direction. And it's going to be in the direction we would expect. So -6 is going to be a translation down 6 units. So we associate negative with being in the downward direction for vertical, and so that's exactly it. So my vertex then is going to be located at 0, -6. So I'm going to just move down 6 units, and so that's going to be the location of my vertex. And then it's this pattern that I mentioned already, that I'm going to go over 1 in both directions and up 1. And then I'm going to go over 2 from the origin, not from these 2 points that I just generated, but going back to the vertex, I mean. So I go over 2, and I'm going to go up 4. And again, that happens on both sides because these graphs are symmetrical. And then again, to get one more set of points, even though these weren't in the t-table, we can go over 3 from the vertex in each direction and go up 9. So again, that's 9 from the vertex, not from the origin. And so then we can see the exact same U-shaped graph. And again, it's very important. These are not straight lines. There is a curve to these, so they are different from our absolute value functions. But again, in this case, with the minus 6 happening outside of the x squared, after the x squared is taking place, it translates the graph down 6 units. On the second example, we see a plus 4 on this one, but that's happening inside of the parentheses before the squaring takes place. And so, again, because this is happening inside of the function, it's affecting the input rather than the output, and so as a result, it's going to move the graph in the horizontal direction. And just like it was with the absolute value functions, it's going to be a translation in the opposite direction that we would normally expect. So we're indeed going to have a translation. So plus 4, positive we normally think to the right, but instead that's going to be to the left. So it's going to be a translation left 4 units. So I'm going to go to the left 4, 1, 2, 3, 4, and then I'm going to go over 1, up 1 in both directions, just like we did last time. I'm going to go over 2, up 4 in both directions, and then again over 3, up 9 in both directions, always referring back to the vertex, to wherever that starting point, the bottommost point of my graph is. So once more, I've got a U-shaped graph that I generate right here. In our third and final example, we can see that there are 2 different transformations that are happening, 2 different translations. We have the minus 3 on the inside of the parentheses before the square is taking place. Then we have the plus 2 that comes after it. So starting with the minus 3, like we saw in the previous example, so that's going to cause a translation that's going to be, again, the opposite of the horizontal direction that we would expect with a negative. So it's going to be to the right 3 units. So that's going to move my vertex from the origin to the right 3. But then I also have this plus 2 that's happening on the outside of the function. So that's going to move us in the vertical direction. So that's going to move us up 2 units. And so from the origin, if I use that as kind of my basis point, I'm going to move to the right 3 and up 2. So that's going to be my new vertex location. So I'll take this one away just so it's not a distraction. And then from there, we're going to use that same pattern. To the left and right 1 and up 1. To the left and right from the vertex 2 and up 4. And then again to the left and right 3 and up 9, which is going to take me just above my 10 by 10 grid here. So I'll just kind of estimate those 2 locations. Oops, we ended up with a straight point there. So I'll fix that. And so now, again, it's the same U shape in every case. We've just translated it around the coordinate plane. We have not done any dilations. We haven't done any reflections, just translations left, right, because of the number being added or subtracted on the inside, up and down because of the number that's being added or subtracted on the outside of the square.